Hello, everybody, and welcome to SurrealDB stream number 11. For this stream, we got in touch with our community on Discord and we said, what would you like us to talk about today? We're joined by the brilliant Misha, Alex, and our co-founder, Toby. And you have come back to us saying that you'd love to hear about data modeling, performance, transactions. So that's what we're going to be discussing today. As ever at our SurrealDB stream, say where you're watching in from. We always love to see you. Hello to Luca, all the way from Italy. It's great to have you on here. Hope you've been having a good week. We've been really busy in the office, of course, working on version 1.0, which is going to be released in September. And we've, of course, also welcomed Akanksha, who is joining the team as a senior front-end engineer. She's going to be working, specializes in the Ember.js framework, and she'll be focusing on front-end user experience, user interfaces and websites, and of course, the launch of the SurrealDB dashboard, which we're very excited to bring to you. Today, let's hand over though. Oh, Luca, it's brilliant to hear from you. We always love to hear from the community, and a proper reminder for anyone watching, do post any questions you have in here. Toby and Alex and Misha are going to be looking at them throughout the stream. So do post them as we go along. And I'll hand over to Toby now. Welcome.
Hey, great to be here. Thank you, Lizzie. Yeah, I've got an exciting one today. We're looking in more depth at SurrealQL. I've got some exciting things that we'll be looking over from the community and looking into, as always, different ways that you can use SurrealQL and touching on more of the functionality and looking a little bit ahead also towards what we're going to be having coming into our latest release in September. So Alexander, welcome. Misha, welcome. Great to have you here. I guess the question is, where should we start? There's so much to cover. Where should we start?
So yeah, for this week, we thought we've done 10 streams now, and we've been focusing on subjects that we've decided for ourselves, and we thought it might be a nice one to ask the community for questions this time around. And so we did that, and we got some questions in. So let's just hop straight into them. So we've got a question by Darkholm about transactions spanning different requests. So this is something that's already been asked a few times, and there's actually an issue on GitHub for this. This is something that we are planning to work on in the future, though at the moment transactions are really focused rather on, for example, to try out how data change would affect your database, right? So you can start a transaction and you can cancel it, or to ensure that every query inside of that transaction gets executed successfully without any issues, to ensure that a data change is made correctly, so without any unexpected behavior, to say the least. So transactions weren't built with such a feature in mind initially, but this is something that we want to look into in the future.
Yeah, definitely. I think the main thing there is, it's definitely able to be supported, but in order to make that work across the API boundary, we need to have kind of not session identifiers, but transaction identifiers that get pushed down to the client, and then that is used in that request. So it's definitely possible. It's something we'll be looking to add in the future, definitely.
Then another question by Darkholm was about an official .NET client. We actually have somebody in the community that is currently contributing into the .NET client and implementing a lot of functionality. David O'Donnell, you might have seen him pass along in the Discord server. It is still in draft at the moment, but once that gets ready, we will look into that to get it merged.
We've got a question here. We've got a question here also from David Tai on YouTube. David, great to have you with us, and hi also to Luca. Enjoying your holiday, I hope. Is it in the roadmap and possible to make SurrealDB work on top of Cloudflare workers, so V8 and runtime, and also using the D1 KV store? So I guess there are two questions there. The first one is, can we use SurrealDB.js or SurrealDB.wasm on top of Cloudflare workers? And then whether that could use the KV store. I'm going to guess that question is related to using the KV store and D1 from within the worker rather than using it as a data store. To answer the last part of that question, we can't use KV or D1 as a data store itself because of the way that transactions work. So SerealDB needs certain guarantees with the in order to implement a storage engine. And one of those guarantees is it needs to have transaction support over range queries, and the key value store needs to be range ordered as well. So very specific requirements for the key value storage engine. But in terms of, I'll let Misha talk about SerealDB.js on Cloudflare workers, and obviously using D1 and KV to store data within the Cloudflare worker itself.
So in terms of SerealDB.js, the library, there are currently two strategies being implemented. The official one is the WebSocket strategy. So this is used across most SDKs that we currently officially support. I don't think that the WASM variant to say currently is supported in Cloudflare workers, because the WebSocket implementation in Cloudflare workers is different from web browsers, Deno, Node, etc. We might look into a way to get that working with, I think they're called durable objects in the future, but it's not a priority as of now. Something different you can use, however, is the experimental HTTP strategy, which is currently being exported by the package. This essentially is a compatible implementation, JavaScript and TypeScript wise, but then communicating over HTTP. And this should work out of the box. You might need to pass along a fetch function to the driver, but besides that will work in Cloudflare workers out of the box. When it comes to the WASM module, I haven't tested it, and I don't know how that would work, so I can't answer that at the moment. I do know that Cloudflare workers do support Rust code as well, so we might look into in the future into getting a like a Rust module to work in Cloudflare workers, but it's not a priority as of now.
I keep forgetting to turn myself on mute here. Yeah, absolutely. I think that might be something worth testing when the WebAssembly library is actually released as its first kind of beta version. It'd be interesting to know how well it performs or works on Cloudflare, and if it doesn't. Obviously, with a WebAssembly library, you can connect over HTTP, WebSockets, as well as run your own local instance. So, really depends on the functionality you want to use. We've got another question here, which actually we're going to touch on a little bit, from Luca. I'll bring it up. So this question is, in terms of performance, is it better to have relationships as record links or as graph nodes and edges? We're going to touch on that in a little bit, Luca. So we'll come back to that question. And your second question as well regarding indexes, we'll touch on that as well. Before we move on to that specific question, we've got a question here from Gish. Gish, welcome. Great to have you here. Are there plans to implement a schema data migration solution in SerealDB itself, or is this a thing you'd like the community to tackle? So that's a good question. We get that one a lot. We do have plans to add our own migration or schema definition language, and therefore support data migration and schema migration in due course. Currently, though, you can take a look at this awesome library, which is being created by David O'Donoghue. Misha mentioned him earlier. He's also working on a .NET driver. This is an awesome library. It supports migrating of schema for kind of branching, but also it's also got new features coming soon for data migration of an entire database. So really cool, an incredibly thorough README. So definitely check that out if you're looking to do migrations already on SerealDB. So I guess Alexander, Misha, we should jump into that kind of brilliant example that we're going to be going through, which looks at the benefits between graph edges, record links, or embedding data right within specific records.
Yeah, so one of the questions from the community was, could you make an example data model of how you could structure like a data structure where you would have like a post and then comment, and then people can comment on different comments as well. So it would be like recursive comments, a bit like how Reddit does it. And we worked out a little example schema for that. So if you could put on my screen, there we go. So in this example, we have a table for persons, for people. We have a table for posts, and we have a table for comments. The post contains fields like a title, content, a link to an author. So that's a record link, as you can see here. We'll get back to this one in just a little bit. And for the comment table, we have every comment will have content. Again, a link to a person for the author, and we have an on field because the comment is placed on a different resource, so on a post or on a different comment. Then you can see this comments field, which uses a future to computate which comments have been placed on that very resource. And because like you would have a post, and the post would have comments, right? Then that comment can also have comments. And because of this field, because you're selecting everything from that comment again, it will basically loop through, and you'll get a recursive structure of comments on a resource. How this looks in practice is you would have like two people, for example, here, a person John and a person Mary. And we'll have two posts, post 1 and post 2, one by John and one by Mary. And we'll have some comments. So for example, we have a comment on a post, as you can see, and we have a comment on another comment. So that's where the recursive data structure comes into play. And for the final statement, we select all the resources that we've just created to showcase how this will look in practice. So you've got the comments, and you can already see sort of here that you've got a comment, and that comment has got another comment. But the place where you can really see this is when you look at the posts. So we have post number 1 here. That post has got some comments. So we've got one comment here. That's the first comment. And then that comment also has comments again, and that's caused by the comments future field, which means that that the field is being computed once you select the data. Which has got another comment that was placed onto that comment. So this is one way to do it. Currently, when talking about recursive data structures, it's not possible to do such a thing with graphs, which is something that we are looking into doing in the future. There's actually a GitHub issue open for this, I believe. So yeah, we'll be sharing this in Discord as well, so you can sort of experiment with this yourself. And we hope that it answers your question.
Misha, it's an interesting point that you can't do arbitrary depth graph traversal at the moment, but you can actually use a future to look at the current records graph edges and do a similar thing, but instead of looking through the entire comment table, you could look through just linked comments, couldn't you?
You could, yeah. Futures are very powerful.
Futures are powerful. So I think we probably should explain a little bit what a future is and how it works, just for those who are joining us and maybe haven't dived into the documentation just yet. So yeah, I mean, effectively, a future is a block of code that can be run, but it's only run at the point of selection. So it's actually stored, that code there, the return select all from comment query is actually stored in the database and run only when that comment table is selected. And so it's really powerful because you can do anything. You could select any data you wanted to. You could alter that data. You could that future could depend on a field that changes. Maybe it's a date or a birthday or an age field or something like that. And it can change its output value depending on any of the inputs that it receives. So it's really powerful. What do you have in addition to that? What do you have to comment on those on futures?
I think one thing to keep in mind for futures when it comes to performance is that it's lazily evaluated. So if you take the future away and you just kind of like run it and you kind of are running it each time, then you're essentially loading all that data each time. But with a future, you you're essentially only running it if and when you need it.
Interesting, yeah.
An important thing here about the future is that it is being computed once you select it. So you could do the same without a future. So just for this field, return every nested comment. But the issue there, of course, is once a new comment would be placed in like the nested data structure, that field would not be updated because it was only updated once the record itself was being updated by the author or a blog admin or whatever, right? And the future helps to prevent that. The future makes it possible to have that like being live updated essentially.
I think it's probably important to note, we've seen on Discord before, it's very easy to use futures, but sometimes you don't necessarily need them. So this is a great example. As Misha said, if you change that to a normal value, which will get computed on write or when the record is updated, then that will seem to work. But as Misha said, if you add another comment, then that won't appear in that field until you update that record again. With a future, you can obviously always change what's being output in that field because it's always depending on the future value. But vice versa, there are times when you might think you need futures, but you don't. So it really depends on whether your data is changing and is always kind of dependent on the input every single time that you select it. If it isn't, you probably don't need the future. I think it's also probably worth noting that statement inside the future, Misha, is going to be looking over the entire comment table. So it's probably something we'd want to, from a performance impact, especially when you've got thousands and thousands of comments being added to that table, that's going to get slower and slower. So you'd want to change that so it's only looking over a subset of those comments. But a great point to start anyway. So let's carry on with the example.
Yeah, so I just added a small example here about for when not to use a future, because you can see that we're only referencing a field on that same record at this moment, and the record will only change once it's being updated. So you might as well just get rid of the future, which will make it more performant because you don't need to recomputate the result of that field every time the record is selected. You only need to update it when the record is updated because it's only using data from that same record.
Vice versa, if you have a birthday field rather than an age, you'd want to use a future. So it gets it's a very advanced functionality, but it gets can get complicated as well. Anyway, Misha, carry on.
That was actually it for the example. So we'll be sharing this in Discord, and you can sort of experiment with it yourself if you want to. And I think Alex had a comment as well.
Yeah, just to kind of mention that this is, of course, one way of doing it. And we've talked about a little bit about the future versus the non-future. You could, of course, also like have it not in a define statement because a define statement just runs once. But then you're kind of like maybe putting it in an event or like we talked about earlier, that you could also have a kind of recursive graph later down the line once we've kind of implemented some of these graph algorithms. And we're also working on kind of the kind of micro benchmarking and kind of like seeing for these different use cases. We kind of know some of the kind of theoretical performances, but kind of seeing the actual performances is something that we're working on as well.
Yeah, it also brings back this kind of conversation all the way round to how to store your data in the first place. Should we be storing comments as a large array of objects? Should we be storing comments in a separate table? Should we be linking to them to the graph? There's more than just graph or record links, isn't there? There's also, if you're only going to have 15, 20 comments on an article, would it be good to store those comments right on the article itself or the post? Right. And that's something that if you're looking at databases like MongoDB or document databases where you don't really have those table joins, that's really the typical way or the traditional way of doing that, isn't it?
Yeah, absolutely. And oftentimes when we're thinking of performance of different data models, it's always good to think about what like how you're querying it, how your application looks like, because for different scale, a different data model might be more preferential. Like Toby mentioned, if you kind of like have tested and seen that you kind of like your max is only like 10 comments per article on average, it will be much more efficient just to embed it. But if you're seeing that like you're like Hacker News or something where you regularly get like 1,000 or like 10,000 comments, then you're going to have a lot different performance profile, and probably would want to have it in a separate thing.
Absolutely, definitely. I think that's always the most important thing, isn't it? You can't just design a schema. You have to design a schema based on what you think you're going to be needing in the future, and build around that. So, coming back to that, there are loads of different ways you can model your data. You can embed objects and arrays on the record itself. You can use direct record links, as we've done in this example, or you can use graphs as well. But you can still use a functionality that Misha's shown here with the futures to bring those graph records right within the record. So it appears that you've embedded them within the post or the article, but actually they're stored separately. They're efficient to get and traverse, and that can become really powerful.
Yeah, and then later on, as there was a question regarding the live queries, there are also options there where you could like live select from a table, like as and when a comment appears, it will pop up, and that's another option that kind of like allows you to have this kind of little bit less processing at the same time, but we don't really have a prepared example for that. It will be in a later one.
Yeah, definitely. Live queries, we'll be touching on that a little bit more when it launches in non-beta. As Alexander said, if you've put those out into a separate table, you can build interfaces around the changing of data in those separate tables, and that becomes really powerful. Before we carry on, we've got a couple more questions on YouTube. So the first question is, are you planning to offer abstract schemas? They allow you to have a base schema that can be inherited by other tables. Obviously, this would allow them to be used, defined once, then used in different tables. Now, Misha's actually just been doing some internal RFCs on kind of functionality around this. So I mentioned earlier, we've got a schema language coming, and that will enable us to define schemas for the particular objects or tables. But another feature I'll let Misha talk about enables you to define more simple types, and also it's not quite defining types that can be reused, but it enables kind of similar functionality. So Misha, if you detail that a little bit.
Yeah, so we've been brainstorming about various ways to improve typing in SerilQL to make typing more strict, to make typing more declarative, and we've just been looking at various like query languages as well as actual programming languages to see what works best in those different languages, and we're obviously trying to get to the root of like why something works, why something doesn't work, why something sort of works, and what's the best middle ground between them, and what suits the best in SerilQL. So, for example, we've been looking into enums. That's one thing. We were considering string literal types or like literal types overall, but literal types are still a bit basic in that sense, and enums are a great way to overcome that. They can be very powerful when used in the right scenario and with the right tools surrounding it. And in general, just looking over ways to indeed get abstract types so you can reuse them, and just in general stuff like in that area. So and we're hoping to release this kind of stuff in due course. I can't really promise a timeline on that, but it will come with time.
Yeah, so obviously some exciting stuff around enums, and still being a query language, but supporting more programming-like features as well, which will enable you to iterate, query, analyze your data in much more improved ways. I think we've also got plans for specific types. So, for instance, an object, you can define an object which has certain fields, and then you can use that object later when you're defining your fields or your tables. So, albeit not exactly abstract schemas, it will enable you to kind of duplicate up or put fields or define fields onto tables in a more simple way. Let me just think. So Luca has asked a question here about comments. So in terms of performance, and assuming I have thousands of comments, what is better, record links or graph? Let's answer that question directly. So with graph, you're always going to have 5 writes whenever you create a graph edge in between 2 records. So you create the comment, and you have a link, let's say wrote comment, between user and comment, and then the comment might be linked to an article. So you'd have the comment linked to an article, the comment written by user, and with those 2 record links or graph edges, you would have 5 writes. With a record pointer, obviously it's only single direction, so you'd have to create the link backwards, but that would be just a single write, the write of the record itself. So when you're writing, there's obviously a downside to using graphs, but if you're now trying to traverse that, when let's say you want to find all articles that link to this user, or this user has written comments and which articles is it linked to, it's a much more efficient way of querying your data. So to answer your question, Luca, it depends. Again, it depends on how you want to query your data, what type of analytics you want to be offering, or what type of analysis you want to be doing. But it's SerilDB is kind of flexible. You can store data in record links and have them pointing back. I guess it depends on whether you need to be traversing and analyzing who has commented on what and which posts have been commented on by this user and things like that. So I hope that answers your question a little bit better.
Yeah.
And
also,
I mean,
just to
when it comes to reading, it depends. Like at the moment, if you were to write an application like a commenting system like YouTube or Twitter, where you can go like 2 levels deep. So you have a post or a video, you can comment on that, and people can comment on that comment, but it won't go any deeper than that. You would probably be better off with graphs, I'd say, because you can directly traverse to those specific comments. So you'll never need to do a full table scan there. If you need to do recursion at the moment, record links really are your option, because there's not really recursive graphs at the moment.
Yeah. Also, just to add on that, when it comes to performance, you can of course sacrifice, say, a lot of, what you're sacrificing with record links at the moment. While you're getting more performance, you're losing referential integrity, which might be a key thing for you. You're also having less kind of like storage space as you're doing like fewer writes, but then again, your kind of like reads might be a little bit slower. And so performance in kind of the specific area that you want, if it's like read performance or write performance, is kind of a crucial thing also to look at.
Yeah, definitely. And actually, this brings us up back to a question that Luca asked earlier that we skipped over, which is, is it possible to add indexes or indices on the record links themselves? So, for example, person.friend.age, I want to know all the friends of Luca that are over 40. So this isn't possible at the moment. So those record links themselves are literally just traversing the documents as it sees them. So if you have a person record linked to a friend and then that friend's age, it's literally going to be selecting that friend record and then its age from that record as you traverse through. That's an interesting question, isn't it? It's probably not something we'll ever have on record links themselves, but indices on graph edges is definitely something that's more beneficial, because there could be thousands of of graph edges on a particular record, and obviously don't want to brute force range scan over all of them just to select certain things. So indices on record links is definitely something we're probably going to have in the future. But on record links themselves, that's a bit more tricky because as it relates back to what Alexander said before about referential integrity and kind of understanding exactly what data is connected over these relations. So it's much easier with graph edges than it is with record links.
Yeah. Also on that note, with the graphs, there are certain algorithms that might make things a lot easier. So, say for example, if you wanted to know, like who is most similar to this person, or like I want to find a comment that is similar to this comment, you could of course use different ways of doing that. One of them is like similarity search, which you can use in kind of like more data science graph algorithms. And so the graphs are pretty powerful in that sense as well.
Yeah, and don't forget, you can obviously create, if you've got record links pointing to a table and you want to create an index on that table with maybe the comments for that have been created in the last week, or maybe the comments that have been created in the last week by a particular user, you can now create indices on that table, on a comment table, and an index would be defined for the fields user ID or user and date. And then you can obviously more efficiently search through that table easily. So that would obviously be used also when you have a subquery. So there are other more performant ways of using indices, not necessarily just because of the record links or the graph edges, but just simply with a table and then being able to bring those results in to your query as well. Excellent. Before we carry on, we've got a question here from Daniel. I'll go on to that in a minute. What other questions have we had from the community running up to this stream?
So one different question, which I think you, Toby, might be able to answer, is the benefits between using memory versus like file storage. So it's I think that's the full question. Let me quickly verify.
Yeah, the question was.
So what's the difference in performance, and is there a possibility to store the DB on HDD on like the drive, but to have a read-only instance in memory for better reads?
It's a good question. Alexander, did you wanted to add to
that? Yeah, I think the kind of like context around that is if you think of something like Redis. If you're kind of like using SerialDB as a cache layer, could you use SerialDB both as a file database and the cache layer? And kind of like the difference of using the in-memory engine versus the RocksDB engine or the file storage engine. And I guess for like specific hard numbers in different use cases, like we can't answer on the call right now, but we are doing some micro benchmarking for that. But I guess the question is in terms of like, could you use like a file storage and then have SerialDB also be a cache with in-memory on top of that?
Yeah, it's an interesting point. For instance, if you're using SpeedDB or RocksDB, obviously RocksDB being the default, then you automatically have a whole number of caching layers in between the actual storage implementation on disk and the implementation in SerialDB. So if you're using something like RocksDB, you're already benefiting from caching in some aspect, probably, obviously depending on your queries you're running and how often those queries are being run. With the memory instance, it's very different to the characteristics you would see with something like Redis. So with Redis, every single algorithm is properly documented in terms of its complexity, and you would then choose the algorithm you want to use depending on those performance metrics. With SerialDB, underneath the hood for memory instance, it's a B tree. It's a single write, multiple read B tree. So it does give you pretty good performance on the read, but really you're not going to benefit massively over using something like RocksDB or SpeedDB at this point. We do have plans to improve upon our performance in memory. We're working on our own key value store in Rust with our own data structure. which will enable us to have better compression in memory and enable us to offer multiple concurrent writers, multiple concurrent readers at the same time, and also have improved performance over our typical in-memory store. But it's still, if you're looking at something like Redis for a cache perspective, where you don't care about the data in it, but you do care that it's very performant, it's always going to have different characteristics to something like Redis, where it's specifically designed for those particular algorithms and the particular performance complexity of each of those algorithms. So in this case of SerilDB, you probably want to be using RocksDB storage because it's quick, it has a cache, multiple different levels of caching, and at the same time you have the persistence in that it is ACID compliant, it is storing to disk, and you are able to, if your database crashes, you are able to have that data back. The other thing is, unless you've got a really beefy machine with lots of data, obviously if you're storing on disk, you can store terabytes of data. If you're storing in memory, you're going to have a limit based on the number of the amount of data or memory on your machine. So that's something else to bear in mind. With RocksDB, it will store the data that isn't as accessed as much on disk, but for the data that is accessed more, it'll store it in the cache, so in memory cache. So it's going to be performant if you're accessing the same data regularly anyway. Awesome. Let's just come back to Daniel's question then. So let's bring this up and let's see if we can answer it. So from person, get the order and all the order data, and even its relation with product with all of its data. Alexander, I'll let you chat about this because it relates a bit to your SerilDeal dataset.
Yeah. So just to give context, we did create a demo dataset, which you can find on our documentation page called SerilDeal, which has these kinds of tables called product and order and person and all of that. So when we're talking about from person, selecting the get the order and all the order data. So I guess there is a question about, is it possible to do it all in one like graph query? Or is it possible to do it on one query? Or is it possible like overall? So currently when we're doing our graph queries, it's not possible to kind of pick and choose intermediate things. So you cannot, for example, say, I want to select everything from the orders and then go to another relation and I want to select just these 3 fields, and then to another relation and I want to select like everything. You would currently have to just select for one kind of relation, you can select the field that you care about or like all the fields. And we're also conceptualizing how do you kind of select multiple fields in one graph query. But you can definitely have multiple kind of graph relations selecting all the fields that you want.
Yeah, awesome. Daniel, let us know if that answered your question. We're always improving our demo data sets. We've got some more plans coming soon. We're also trying to cover as many features of the database in that. So we've got graph edges, record pointers, aggregate analytical views, futures. We've got a whole load of features in there. So we're trying to demo and give examples for as many features as possible. So we're always improving it. And excellent. Hope that answered your question. We've got another question here from Luca. His question is: would it be possible to keep a table in memory if it's often read? And if yes, will the table work as a normal table with writes to it, or will it be read-only? It's an interesting question, Luca. I don't think we're ever going to support in-memory tables because it's often read. But Alexander, if you want to talk a little bit about the analytical views that I think many people know exist as a feature, really, and if they do, they don't know really how it works. So that's probably relates to that question a little bit.
Yeah, no, absolutely. Oftentimes when you have these kind of tables that are frequently read, you don't want to compute them every time you need them. And so that's why we have these kind of pre-computed views, which we keep saying we need a better name for. But for now, just like you can define a table, you can define kind of a materialized table. So effectively, it's a materialized view that gets incrementally updated as you add in more data. So when you have huge tables, say for analytical purposes, oftentimes you don't want to write the entire table every time. And often you would have some logic that kind of like looks at when it was written and then inserts new data after that date. With SurrealDB, you don't have to actually add this custom logic yourself. With the pre-computed views, once you define them, then it will automatically make two writes, essentially one write to the source table, and then one write to the pre-computed view. So once you kind of add more data, it will essentially automatically come to the pre-computed view. So when you need to read from it, it will be already materialized. So the read speeds will be much faster.
Yeah, that's awesome explanation. Also, to add to that, so your question, Luca, goes on to say, if you're hitting an API server, for instance, and you want to get the user for every single request, I think aggregate analytical views can be used in this situation, because you could say, look, I specifically want to just select US users from this table because I know that this is going to be hit a lot. So instead of searching through all worldwide users, I want to have a kind of a view which is stored on disk. I want to have that view, and I want to just select US users or US customers in that list. So then you could select from that view instead of the full table and just be selecting from a smaller subset of users. But I think it's important to remember that because of the record IDs, you don't have to do a lookup if you want to get a user's ID. Instead of selecting from a table where ID equals 3, you can just go directly to user 3. And because of that, if you're getting that user in an API for every single request, it should be performant, and you shouldn't need to worry about should we have an in-memory table that can do that. Obviously, as you scale and you've got multiple SurrealDB nodes sitting on top of a distributed storage engine, then having an in-memory cached table isn't going to be very easy to scale, because depending on the node that you're connecting to, which node has the most up-to-date data. So really the storage engine is always a source of truth, and it's supposed to be performant, especially when you're doing single record lookups. Got a few more questions here. So Luca, thank you for that question. Hope we answered it. We've got a question here from Hossein. Hossein, great to have you on YouTube. It's a good question. So with the Rust server-side library, the Rust client SDK, really you can, there's going to be a slight performance difference between writing Rust code and a SurrealQL query, because with the SurrealQL query, it's being parsed. However, it is being parsed on the client side, and it's being sent over the API connection, whether that's to the local node or to a remote node, as a binary, a piece of binary data. However, we are working on, it's not going to be ready just yet, we're working on it for the future. We're working on a compile time macro that will enable you to write SurrealQL code. It's actually compiled into bytecode or binary data right within your compilation, and then you can send that query, maybe with parameters inserted at a later date, to a local node or a remote node. So we've got some changes and improvements there coming, but really there's not going to be a massive difference between running a SurrealQL query and writing your Rust code. It's parsing it locally. It's running in Rust. It's pretty fast already. But yeah, we've definitely got some improvements coming down the line for that anyway.
And I would surely like you to hook into that, because there was also a question from the community about essentially how to use the binary protocol for the WebSocket. And I think that your answer here actually kind of explained that already. because in a Rust SDK, we parse the query on the client side, and then we send it over as like a sort of a parsed message to the server, which is the way that the binary protocol operates. So instead of the text protocol where you just send a query over and it will just run it, it will parse it on the server side. With the binary protocol, you need to parse the query on the client side and then send it over to the server. And this makes it difficult to implement the binary protocol in different languages. We need the Rust bit, like the SerilQL parser, to be like to run on the client first. So we need like Rust or C bindings to make that work, and then we can implement connections over the binary protocol for all of these different languages like Node.js, Deno, etc.
Absolutely, and we've got plans to support a number of these languages. And if we don't support it, we'll be supporting a C binding, which will enable other languages like Erlang and Dart to sit on top of that C library and support the binary protocol and the parsing on the client side. So definitely got big plans for improving that. But going back to your question, Hossein, there shouldn't really be much difference between parsing it and writing it immediately in the Rust code. Zafar, just to answer your question about SpeedDB, it's currently in the source code, but you have to build it from source, only because you can't release SpeedDB and RocksDB at the same time. It's potentially something we'll switch over in the future when we know that SpeedDB and the performance and the stability is equal to or greater than RocksDB. But at the moment, RocksDB is a default file engine, storage engine used, and if you want to use SpeedDB, you can just build it from source with the SpeedDB as the feature enabled. So yeah, already in the source code, already supported. Anything else that we wanted to touch on today, maybe from the community before we finish the stream?
There was a question about how live queries work under the hood, but I think that a separate live stream on live queries is better suited for that, as it's kind of a broad topic. So
Yeah.
Once that's released, we'll do another live stream on that to further go into the details of how live queries work and under the hood. And
yeah, and just to mention, we already had a previous live stream which you can find on YouTube about live queries as well.
Yeah, brilliant. No, Alexander, definitely. There's you can see all of these streams that we've done over the last 6 months on our YouTube channel. Definitely jump in to see. There's a brilliant one on indexing, a brilliant one on live queries, and multiple streams on SerilQL itself. For specific questions to the team, you can jump on our Discord every or most Thursdays. So next week or every 2 weeks, and you can also talk to the team on Fridays, where every Friday we've got a bug-free Fridays where we work through issues and feature requests on GitHub, and you can talk to the team about and a member of the engineering team about specific features or specific questions about those. Not bug-free Fridays, sorry, developer office hours. There you go. So yeah, let's just see if we can answer one more question from Gish before we end. So, is there a way, or are you planning to abstract away the web endpoints? So these could be a concrete implementation for multiple web libraries. I think there's a feature request on GitHub for this, actually, so that actually we put each of the web functionality into its own package, own internal crate, as it were, and then that would enable people to build on top of those. So it's not planned at the moment. Obviously, we're working on features for the database and stability and performance, but it's definitely something we'll think about for the future. If you want to talk more about that, then, as I say, I'll be on a Discord stage next Thursday, and or just chat with a member of the team on Discord itself. Awesome. I mean, this has been great. So, just before we finish, is there anything else you two think would be kind of that we haven't touched on that might be good to mention to our viewers?
So much.
Yeah, I think probably just the last thing is just to mention our SerialDB conference that is happening on September 13. You'll find a lot more exciting announcements and a lot of the ways kind of like we want to see the kind of database industry move forward too.
Awesome. Yeah, Alexander, definitely. Just to kind of go a bit more in depth on that, it's an all-day conference in person in London, or we'll be streaming it online as well. If you can make it in person, that'd be great. We've got some custom swag being given out to people who attend the conference in person. I'm sure you're going to love it. In addition to that, we've got some really exciting features that we've been working on internally. We haven't actually announced yet. So really excited to be getting towards September the 13th to our official 1.0 launch. And until then, see you on Discord, see you on YouTube. Thanks for watching. Alexander, Misha, and Lizzie earlier, thank you. Great time flies on these streams. 53 minutes already, but yeah, great to touch, I guess, on SerialQL, and see us in a couple of weeks' time where we'll be diving into another SerialQL feature. So everyone, thank you for joining us, and see you again soon.